This video is sponsored by PCBWay. It is time to look at upgrading and improving stickers, my beetle tangent drive vert. We found a couple of problems and I think we can fix them all today. So in the previous fights we've realized that the wheel size is highly critical and that when I made my own, they shrunk out of the molds, meaning that they didn't work with the tangent drive system. So that should be an easy fix. We also want to look at the weapon system here. This weapon motor isn't all that great. It's too low a KV, meaning that we've got a 1-to-1 reduction, which means there's not a lot of torque spinning the weapon. Also, we have a static bar here of HDPE that is doing the belt tensioning, and that has been eaten away. On top of this, I'm currently using an ABS print to mount the tangent drive motors in, and I just want to make that a little bit more rigid because I have a sneaking suspicion that that might be causing some deflection in the drive system and maybe making the wheels not touch perfectly. So let's start with the drive because I have one wheel already molded that should be big enough, and if it's not, I need to adjust my molds before we do another round. Okay, so we're gonna replace this front wheel for two reasons. One, it's the easiest wheel for me to get to, and two, it has the most constraints because it has to fit behind our front armor and also touch back here, which just needs two screws taken out to release the mounting bar here, or the tensioning bar, and then we can get access to the back of the bolt holding the wheel on. Like so, and then yeah, belt tension entirely gone, so we can spin the motor without spinning the weapon at all, which is not great. And then that's the bolt down there, which is fairly easy to grab hold of now and undo. So then we've got our new wheel, which we're actually going to take out the bushings out of this wheel. This is the old wheel that we were running, as you can see by the wear marks on it. We're going to take those bushings out and put them into the new one. And now this wheel goes on pretty easily. So it is literally just bolt all the way through. And then the bearing stack up, we've got a thrust bearing in here to keep everything spaced and also to stop the wheel from touching the actual chassis itself. And then all we need to do, pop that in there, like so, and test the fit. I mean, we don't even need to tighten this bolt down to test the fit because it does just go. Look at that. That is working. I'm not sure if you can hear that, but that is making full contact all the way around. And in fact, it's like, that's perfect. That's exactly what we need because it looks like, and it's really, really hard to show in here, but it is, the polyurethane is actually like denting in where that is contacting, which is good because that means we've got a few millimeters of wear before it will. Okay, that's great. So with that, we are going to print more molds for this and we're going to make a bunch more of these. The molds get coated in a water-based mold release, just applying it absolutely everywhere, trying to get as much on as possible. After that's left to dry for a little bit, the molds then get bolted together to make sure everything sits down square and round. And then the wheel hubs get bolted in as well. With the molds and hubs all set up, it is time to actually cast the wheels, which involves mixing up a bunch of polyurethane. The biggest and most important step in this is making sure it gets mixed correctly, which means mixing it for at least 2 minutes. And then the mix gets poured into all of the wheels, one after another. Here I did kind of run out on the fourth wheel, but that's okay, that was just a spare anyway. While those wheels are curing, let's look at the rest of the hardware, and we're going to start with these, which are the motor mounting plates for the brushless tangent drive. And look, these are printed in ABS. They are flimsy. There's not a lot of material in the corners where they bolt together. So all of this just needs an upgrade. And that's where PCBWay comes in. I have designed up these PCBs, which are the perfect mounting solution for these Repeat Robotics tangent drive motors. Because PCBs are fiberglass boards, this is basically a fiberglass motor mount, which means that it is lighter and stronger than that 3D print that I threw away before. If you want to run some tangent drive and need mounting plates like this yourself, I will leave a link to a download of this design file in the description, and from there it is fairly easy to get these ordered through PCBWay. You literally just put in the dimensions, get a quote, and then upload the Gerber file, again linked in the description down below, and you will have your own motor mounting solution. So these should fix a problem before it happens, I hope. We now need to actually put them into the robot, which means taking stickers apart. As far as my robots go, stickers actually isn't super complicated of a design. It is pretty easy to take it apart, but it does just require a couple of different tools. Looking at this plate that's come off, we can see a little bit of wear on this plate. So this is the front armor panel, and this little wear would be from the wheel itself. Because we're adding in these new polyurethane wheels that are, I think, slightly bigger than these, I might actually need to cut a little clearance in the back of this panel and print whole new versions of this. All right, I'm gonna take a lot of screws out here, and then we'll move on. The other thing I want to look at doing while we are working on stickers is making the stickers stick down better. These are just sticking onto HDPE right now, which means that they're actually fairly easy to pull off. And my opponents are doing that. They are actually damaging all of my stickers as we go through. And I think I've got a way to make the stickers stick better to the robot. So that was quite a pain to get out because of this, the screw head that broke off in the HDPE. So that meant it was hooked into the base plate down there and also hooked into this. I ended up having to like hammer this a lot to get it out. I hammered it here on the bench, and I also took it into my workshop and hit it with an M6 bolt and a hammer to actually finally get it to give way. It's the only downside to this kind of box setup that I usually like to do for beetle weights is that if a head breaks off of a screw, it is almost impossible to get the pieces back apart again when you need to do maintenance or replacements like I'm doing here. So there we go. I have the motors out now, and yeah, as expected, these are breaking at the corners, so they probably wouldn't have lasted another round of fights anyway. And I've got the chassis as far down as I'm gonna take the chassis at this point. I've also printed up a new motor mount, which is just sitting in here for the moment, but I'm gonna take that back out because the next thing is going to be to apply stickers. Well, take these stickers off and apply some more stickers. So the thing I'm gonna try is I'm gonna try some contact adhesive spray, but that means spraying down the whole robot, and that actually means that I need to mask off areas that I don't want contact adhesive in, which there's a decent number of those, like in all of these gaps and things with hold down lids, because that is just going to make my life harder if I get contact adhesive in there. So my next hour or so probably is masking huge sections of this. So now the glue has got slightly tacky, which means it's time to stick some stickers on, and I have a lot of options for stickers here. I may have gone a little bit overboard in the kind of intervening time buying new stickers to put on stickers. To be fair, a lot of the space I have is fairly small, so I have to be fairly choosy with what I'm actually putting on stickers and where. I am going to try and go for a very cacophonous look, just jamming stickers here, there, and everywhere in this thing. Just way more than I had even the last time we did this. The back is my biggest kind of canvas space. Everywhere else around here, like the railings and things, and even inside bits, I don't have a whole lot of actual space. So a lot of these big stickers just aren't gonna go anywhere, at least for now. When we get the armor panels, I can put on some bigger stickers on the armor panels and things, and the lid I can put some stickers on as well. But yeah, for the most part, I'm gonna need to use the little stickers that I've got. So I've got some emojis in here, I've got some phrases, I've got some sparkly animals down the bottom here, got some shapes which I'm hoping I can use to like fill out spaces and things. I've got some wizard stickers as well. Just, you know, I'm gonna have a bit of a time here applying lots and lots of different stickers to stickers. So we are getting somewhere. Stickers is getting very stickered up. Obviously the bottom has not been done because I haven't sprayed this section yet. That's going to be interesting with this. I might have to work out some way of like protecting everything other than the base when I spray. Because yeah, we don't really want more glue on the stickers that we've already put down because I don't need it really. I can also probably put some more along here. I might do that. There's a couple more spaces I can put some more down. I probably am not finished with this. I'll probably put the whole robot back together and then add even more stickers afterwards. But this is just trying to get stickers into places that are going to be difficult to get to once I've got wheels and stuff on here. I really want this to be a bit of a cacophony, and the best way to do that is to like throw that down. And then, where's my monster book gone? I'm going to grab a monster out of the monster book because I haven't used any of the monsters in here yet. Who do we like? Who's going to fit? Maybe we get the fire turtle, I think. That's going to be kind of cool. Yeah, we can do a fire turtle down the bottom. Do a kind of Bowser-esque monster. Come here, buddy. There you are. So I'm going to try and overlap that with the one I've already done, just because, again, I need to get myself more comfortable with doing stuff like that, which is horrible. This doesn't look great, but as part of a just mess of stickers on this thing, it will look better. You know what? I actually kind of don't hate that. Yeah, we're going to go upside down with the Yeti. I mean, the Yeti's got a hard job because it is covering over some very large damage pieces in this robot, but that's okay. That's actually not looking too bad. Cool. All right, that's our backplate. So now it's time to spray the bottom and do that as well. I don't think I'll bring you guys along for this bit. I'm just gonna go ahead and do the bottom as well. And then we're gonna look at actually putting the whole robot back together. Put stickers on the base as well, including a bunch of little helps, which I think is gonna be quite funny. This isn't every sticker that's going to end up on this robot, but it's enough for now for me to be okay putting all the rest of the parts on, and then I'll cover some more gaps later. I don't really want to place some like on here and things, which you're just not going to be able to see by the time we've got our PCB cover and then a wheel over it and stuff. That's all just not going to work. So as we've done before with motors, we're going to use some Loctite to keep this all together. It's a fine balance Loctite in motors though, because you don't want to put too much Loctite in so that there's enough Loctite to seize up the motor, but you do actually want it to do its job and keep the bolts in place, or keep the screws in place that you're putting in. And in this particular case, we really don't want or need all that much. There's only a tiny amount of screw thread actually holding this motor in, and as I've done before, I'm going to feed everything in dry, make sure all the holes line up, and then I will turn around and I will put Loctite on each and every one of these. Much like the last plates, these go in fairly similarly, so we want to feed the cables in one at a time, or feed the plugs through one at a time, because it is slightly tighter fit in this clearance hole than I was intending it to be. I did open it up just a little bit while I was in the robot, but it still needs to be done one at a time. Then when things sit down, we put in long M4 bolts that get nylocked at the back and hold everything in place. And then we just do this on both sides. Drive motor's in now. It is time to look at the new weapon motor. This one is a little bit squatter than the last one, but it is the same diameter, so I'm hoping that'll work, especially as we've got a 2-to-1 pulley ratio now going out to the weapon. So it should give it a lot more torque, a lot more startup, and around the same theoretical top speed as the last setup. But you know, we might actually be able to get there this time, because I definitely don't think the last version was getting anywhere near its theoretical top speed. Again, I have to feed brushless wires one at a time through a hole in a wall, because I designed this all very similarly, and then this 3D print just clicks into some holes underneath, and then we bolt it in there as well. Ideally, this will become HDPE at some point, but for now I'm gonna run with this because it's a 3D print and it's easier to do. If it works, we'll swap it out for HDPE. We're using a shorter weapon belt, so we don't need tensioning. We're just gonna adjust basically the pulley size to get the tensioning just right. At the moment, we've got a 2-to-1 pulley, but I also printed up some smaller variants as well, so I can adjust these as we need to, all the way down 4 or 5 teeth, and actually get our belt tensioning pretty spot on. Hopefully close enough that we don't need active belt tensioning or even passive belt tensioning. So I've been tinkering around with this. I've dropped it down to the smallest pulley so that the weapon stack fits on nicely. But with that, our wheels are now ready to go, so we can go ahead and take them out of the molds. This process is really easy. I dumped them in a sink full of hot water. This dissolves the mold release that we have in there and makes the next steps a lot easier, which is jamming a screwdriver in between the top and bottom molds, separating those two out so that the bottom comes away. Then we use a smaller screwdriver to separate the sides off the actual wheels. This is done to avoid peeling the newly cast tire off the hub itself. And after a little bit of cleanup, here we go. We have 3 wheels ready to go. These are slightly different thicknesses. You can see these two have less polyurethane on them than this one, and on the one that we cast, or I cast before the video. That is for weight distribution reasons. These guys, the thicker ones, are heavier, so they're gonna sit at the back of the robot and hopefully kind of counterbalance the massive weapon that sits up the front. But it is time to actually put these into the robot. Okay, wheels are on and it's looking good. I mean, we're definitely gonna need to put some stickers on these wheels, but I will do that later. The good thing is that when I turn wheels, everything moves. There are no dead spots or flat spots at all, which is really, really good to see. This is exactly what I wanted out of this system. In the old wheels, these ones, because they're just rubber glued to 3D prints, there are some flat spots where the rubber wore away faster than other points, and that meant that these ones didn't work as well as these ones. Hopefully will. So that's all good. The next thing I've got to do is put in all the wiring and just get everything sorted out so that the wheels turn the right way and things. All of that's fairly easy to do, so I'm going to do that off camera. And then we'll get on to doing some testing. All right, we are powered up inside the box. Let's try a drive test. I mean, there's not a whole lot of space in here, so we're just gonna do a little quick one. That's looking good, and now a weapon test. So that went really quite well, actually. Despite the shorter motor, the weapon got up to speed really quite quickly and was spinning fast enough to give us small amounts of gyro when I was turning, which is great. I can possibly get the motor up a little bit faster, but that will mean new belts and new pulleys and just a whole new system in there, basically. I will deal with that later. I just want to get this version in the arena and see if anything else breaks. It did also drive pretty well, which was really good to see, and despite spinning around and also doing stopping and starting, which would be bad for the friction on the wheels, I haven't actually managed to wear a dead spot into any of the wheels. All 4 of them are still moving exactly as they were at the start, which is good and seems to kind of indicate that this will hold up a little bit better than the old system did or the old wheels did. I am going to make a spare set of these wheels because I don't think I'm going to rely on just having 4 of them for a tournament, but yeah, it seemed to work pretty well. I have also now put some more stickers on stickers, so here is the final version. Stickers now looks absolutely insane. This is just, it's a cacophony of stickers and I actually kind of like the look of it. If you've made it all the way here to the very end of the video, thank you for watching the entire way through. Leave a comment down below and let me know what your favorite sticker is on stickers at this point in time. Obviously, these stickers are going to be very temporary. One hit and many stickers are going to come off and go flying through the arena. I will be bringing my entire stock of stickers with me to the next event to make sure that I continue to reapply stickers as we go through. Just to keep the look alive, you know? Anyway, I hope you have enjoyed this one, and I will see you in the next video.